Welcome to the session on finding unknown angles on straight lines, in triangles, and in quadrilaterals. The objectives for this session are to recall the definition of an angle, determine the sum of angles on a straight line, in a triangle, and in a quadrilateral, and calculate angles on a straight line, in a triangle, and in a quadrilateral. An angle is formed by two distinct lines with the same endpoint, as shown in the diagram. The common endpoint is called the vertex, and the angle is denoted by O, or AOB, or BOA, given the notation in the diagram. Note in particular that O is labelled as the endpoint. The symbol for an angle is as shown. This is a protractor. It helps you to measure angles. We will use it in this unit to help us measure and draw angles of particular sizes. Look closely at this protractor. It is semicircular and has 180 equally spaced intervals marked on it. On the right-hand side is 0 degrees, shown here, and on the left is 180 degrees. In the middle, we have 90 degrees. Let's measure the angle in the previous example by using our protractor. Position the protractor so that its horizontal line is lined up with one of the rays, say OB, of the angle, and the midpoint of the protractor is positioned at the vertex of the angle. Now look at the mark towards which the other ray of the angle is pointing. This value is the size of the angle. In our example, the angle is approximately 46 degrees. A 90-degree angle is a right angle. Angle ABC is a right angle as the measure of ABC is 90 degrees. Angles on a straight line add up to 180 degrees. Let's see if we can find missing angles on a straight line. In the diagram shown on your screen, find the missing angle. The missing angle COD is 180 degrees minus 99 degrees minus 36 degrees. So here's the angle COD. All the angles on a straight line add up to 180 degrees. So in order to find this angle COD, we need to take the 180 degrees and subtract from it the other angles on the straight line. So we need to subtract 99 degrees, and we also need to subtract 36 degrees. This gives us 45 degrees. So angle COD is equal to 45 degrees. Angles in a triangle also add up to 180 degrees. Let's find the missing angle in the triangle. In this example, find the missing angle. Since the angles in a triangle add up to 180 degrees, the missing angle BCA is equal to 180 degrees minus 99 degrees, which is one of the other angles, minus 32 degrees, which is the size of the third angle. This gives us 49 degrees. Now let's take a look at quadrilaterals. The angles in a quadrilateral add up to 360 degrees. So in the diagram on your screen, if we would like to find the missing angle BCD, then we need to take 360 degrees and subtract all the other angles from it. So we have that the missing angle BCD is equal to 360 degrees minus 97 degrees minus 66 degrees minus 76 degrees, which is equal to 121 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to recall the definition of an angle, determine the sum of angles on a straight line, in a triangle, and in a quadrilateral, and calculate angles on a straight line, in a triangle, and in a quadrilateral. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.